Okay, let's look at some general logarithms. So these bits of information are both basically the same. If I'm told that a to the power x equals b, that is essentially the same statement as log base a of b equals x. That's how we rearrange logarithms. And the same is true here. A to the power y equals c, then log base a of c will equal y. So we want to try and derive some rules of logarithms. We know some rules about powers, so let's try and use those to understand something about logarithms. So we know that ax times by ay, we know from our laws of indices we can add the powers. Okay, let's take logs of both sides. So if I say that I'm taking logs of both sides, I'm going to choose log base a as these are both a to the power of something. And if I take logarithms, I just put everything on the left-hand side inside a logarithm and everything on the right-hand side inside a logarithm. I must use the same base on both sides. Okay, so we'll stick with this for now. But if I look at this, I can simplify this a little bit. I know that this is saying a to the power of what will give me a to the power of x plus y. That's almost a trivial question because I know that a to the power of x plus y will give me a to the power of x plus y. So I can replace this side with x plus y. You can think of it as log base a being the inverse operation of a to the power. So these two essentially cancel each other out. If I do log base 2 of 2 cubed, I will get 3. 2 to the power of what is equal to 2 cubed. 2 to the power of 3 is equal to 2 cubed. They essentially cancel each other out. Okay, so that has told me that log base a of a to the x, a to the y, which we can write as log base a of that's b and that is c. So that is equal to x plus y. But earlier on, I saw that x was equal to this and y was equal to this. Therefore, I can see that just using my laws of indices, I have similar rules for logarithms. Log of bc is equal to log of b plus log of c. Similar to indices, where I can turn multiplication into addition, here I can also turn a multiplication into an addition. A similar thing will work with division. As we know that division is written as, let's just get a new board, ax over ay is equal to a to the x minus y. Similarly, I could have written that as a to the x times a to the minus y. Remember, a reciprocal is just a negative power. Once I know that, I can just use the same logic to arrive at the fact that log of x minus y is equal to log of x over y. That will simplify down to x minus y, or log b minus log c is equal to log of b over c. Very similar. I can turn a division into a subtraction. Again, similar to our index rules. One final rule that we'll look at, if we come back to this one, I know that a power to a power, say cubed, I would do a times a to the power of 3 times x, or more generally, a to the n would equal a to the n x. So ax to the n is the same as a to the power of n times x. Again, we can take logarithms. So we could just call that b, because a to the x is b. Okay. Rewriting that. Remember, log base a of a will cancel. X n would equal log b, log a of b to the power n, and we know that our x was log base a of b. But we've got n lots of it. So that tells us that we've got log a b to the n is equal to n log a of b. Shorthand for that is you can bring powers to the front. Okay, so quick summary of the rules that we need to know for logarithms. If we have an addition, b, c, we can write that as an addition in two separate logarithms. A division we can write as a subtraction. And a power we can write as a multiplication. We can bring that power to the front. Again, we didn't assume anything about A, B, C, X or Y. These rules are generally true. These are what you need to remember to deal with your logarithms. Okay?